Hello everyone, welcome to the next chapter, continuity and differentiability. So this chapter marks the beginning of your calculus in your 12th standard. So calculus together carries about 44 marks BC. That BC means before Corona, because I don't know what the marking scheme is going to be after the pandemic. So let's hope for the best. I have no idea. So anyways, it will be quite difficult. Some of your portions have also been cut out. So I don't know exactly what the marks it carries, but you can be very sure that it will carry more weightage. Yeah, okay. So these are the chapters that you're going to learn under the chapter, under calculus, which is continuity, differentiability, the application, integrals, its application, and then differential equations. All right. So before we get into differentiability, let's understand the word continuity. So both these words you have heard, okay? This might not be very familiar to you, but the word continuity is very familiar. So it depends on the context of what you are speaking about, okay? I don't know the continuity of what exactly. So that is where the knowledge of the chapter relations and functions could be quite handy to you. That is because if you want to understand this chapter very thoroughly, then the chapter relations and functions, which you have learned in your 11th as well as 12th, is little important. Let's say it's very important. So let's understand the continuity before we understand differentiability. Okay, so let's see. For understanding continuity, you make use of a graph. Okay, so let's say I'm going to define a function f of x is equal to 3 for all values of x greater than 0, and f of x is going to be minus 2 for all values of x less than or equal to 0. Okay, so where did this function come from? It is my wish. I have defined this function. Nobody read. It has come from nowhere. It is my definition. Okay, this function is not given any particular name because, we have already learned about functions that are named, like modulus, signum, then we have constant function. So different functions we have, even identity function, but this is a function that I have defined. Okay, so for understanding all these things, you have to refer to your relations and functions chapter. So this is it. Okay, this is how I define the function f of x is equal to. It's my wish. So I'm going to draw the graph for this function. Okay, so what does this mean? This means y is equal to f of x is equal to this. So where did this y come from? Also, please refer to your relations and functions chapter. So let's draw the graph of this function. I'll start with the y-axis, and here is the x-axis. I'll draw it very quickly. Let's say this is 1, 2, 3, etc. This is 1, 2, 3, or minus. This is minus 1, this is minus 2. Here you have 1, 2, and 3. Okay, this is continuity differentiability chapter, for which I have taken this graph to explain to you what continuity means. Okay, no problem. So let's say for f of x is equal to 3 for all values of x greater than 0. So what are the values of x greater than 0? I can take x as, let's say, 1, 2, 3, etc. Okay, so tell me what is the value of y whenever x is 1. When x is 1, y is 3. What when x is equal to 2? When x is equal to 2, it's again 3. Okay, not minus 3, 3. Then when x is equal to 3, it's again 3. Okay, so if you want to draw the graph for all values of x greater than 0, it is going to be a straight line like this, and we'll define y equal to 3. So that is a graph for the first condition. So for the second condition, for x less than or equal to 0, what are the values that are coming? It is minus 2. So it starts from here. Okay, and for, let's say, what are the values less than or equal to 0? X can take values such as x minus 1, minus 2, minus 3, etc. So this can be, this is 1. When x is equal to minus 1, it is minus 2. When x is equal to minus 2 also, it is minus 2. When x is equal to minus 3 also, it is minus 2, and for so on. So this is a graph like this. Okay, so this happens when x is equal to 0. When x is equal to 0, it is minus 2. Okay, so this point is included. For x greater than 0, so this point, this point is not included, because at x is equal to 0, it is minus 2. It's not 3. Okay, see, it's not 3. So this point is not included. I'll put a note here. I've put a note. Okay, for people who did not understand what this means, it means that this point 3 is not included, which you have already studied in your 11th and 12th standard, that it is marked by a not. That point is not included. Now looking at this graph, can you please tell me if this is if this graph can be drawn without lifting your hand from the plane of this board. Is it possible? Look at this. If you want to draw the graph, it will stop here. And if you want to continue with the graph, then you have to lift your hand, come back to the board, and then draw the rest of the graph. Understood? So you see it has lost its continuity. At which point? At x is equal to 0. Because for all values of x less than 0, the definition of the function is minus 2. For all values of x greater than 0, the definition of function is 3. So I cannot draw this function without lifting my hand. So understood the word continuity? Continuity of what exactly? We are talking about the continuity of a particular function. Okay, so this is not a graph like this or this. So this continuity is not there. It's not continuous. Let's say what is a small point, even if it's 0.01, it is minus 2. Minus 0.01, it's minus 2. If plus 0.01, it is plus 3. Okay. So as a definition, if you want to write, you can write if a function is not, if a function cannot be drawn without lifting your hand from the plane of the board, then it is not a continuous function. That is not the mathematical definition of the definition of continuity. I'm just explaining for you to understand what continuity means. What does it signify? That you cannot draw a graph without lifting your hand. It's broken. It's broken at x is equal to 0. Please note it down. We'll note more details. Please note it down. So what is continuity? So what is continuity? We have defined the function for x greater than 0. And we have defined the function for all x less than 0. Right? No? That is, the function towards the right of x, towards the left of x, both are, the definition of the function is different. Even if, what is the value of the function at x is equal to, let's say, a very small value such as 0.001. Okay, even if it's 0.001, even then y is equal to plus 3. Even if x is equal to minus 0.001, even then y is equal to what? The definition of the function will change to minus 2. Okay, that is, if you remember the terms that we have learned in your chapter limits and derivatives, we understand that limit x tends to 0 minus f of x, okay, 0 minus, that is a value very close to 0 from the left side, it is not equal to limit x tends to 0 plus of f of x. Okay, that is left hand limit, sorry, the left hand limit is not equal to the right hand limit. That is the first thing you learn. So let's say for a function to be continuous, first thing we understand is what? First thing we understand is that the first thing that we understand is LHL should be equal to RHL. It's not equal to, it should be equal to RHL. That is the first condition we learned when it comes to continuity. Understood, no? Towards the right and towards the left, it should be same. That is, this graph should not be there. Even towards the right also, it should be something like this. Yeah, that is at 0. So let's not understand with this graph. Let's draw another graph and understand. Okay. So the first condition that you understand is limit to the left and to the right, it should be same. Okay, please note it down. Okay, so with the previous understanding, we have come to the conclusion that, you know, for the first condition, that is the first condition for a function to be continuous, is that the LHL should be equal to RHL. Okay, that's what we have learned first. But is it enough? Is it enough? Let's define another function. Let's look at another function and check out. Let's say f of x is equal to, let's say the function is 2 for all values of x not equal to 0, and the function is 1 for all values of x equal to 0. Okay, or let's take it the other way. Let this be 1 and let this be 2. Okay, for ease of drawing. So this is, I have defined this function. Okay, this is my function. I have defined it my way. So for making you understand continuity, what do we do? How do we check continuity? We'll just draw a graph for this function. This is 1, 2, 3. This is minus 1, minus 2, minus 3. This is minus 1, this is minus 2, minus 3. It is 0, this is 1, this is 2, 3. Okay, so let's draw the graph for x not equal to 0. What are the values of possible values of x not equal to 0? X can be -4, -3, -2, -1, 0, 1, 2, 3, etc. Okay. For x is equal to 1, it's 1. For x is equal to 2 also, it is 1. For x is equal to 3, everything it is going to be 1. So it's a straight line like this. Correct? So what about for x less than 0? For x is equal to -1, it's also 1. It's -2. Sorry, see, for -2 also it is 1. So it's a straight line like this. Okay, it looks like a straight line. But what about for x is equal to 0? What is the value of y? What is the value of y when x is equal to 0? It is 2. This is the point. So this is for all values of x not equal to 0. So this point in this line is not there. Okay, that is for x not equal to 0, it is 1. So at x is equal to 0, this point is not there. But for x is equal to 0, what is there? 2 is there. Understood? So this is y equal to 1 and this is 2. This is the point 2, 2. So let's understand. Let's understand with this function. Limit, left hand limit, that is what will be the value of y for a value as small as -0.01? -0.01 for all values of x not equal to 0. What is the value? Y equal to 1. Okay, so can I write like limit x tends to 0 minus of f of x, that is x holds a value very close to 0 from the left side. Okay, it is 1. For the right hand limit, let's say x is equal to 0.01, positive 0.01, that is towards the right. What is the value of y? It is again 1. Okay, so I can write it like limit x tends to 0 plus of f of x, that is the right hand limit. You know, x takes a value very close to 0 but towards the right side of 0, it's again 1. So look at this. Even though limit here also what? Limit, left hand limit is equal to right hand limit. But look at the graph. Look at the graph and tell me, can you draw this graph without lifting your hand from the plane of the board? Is it possible? Is it possible? No. You can draw this graph like this. You can put a knot here. But to mark the point 2, you have to lift your hand and draw the point. Understood? So left hand limit is equal to right hand limit. Even then this function is not continuous. Okay, even then the function is not continuous. So this is only a necessary condition. This is a necessary condition. What is the sufficient condition? What should be the sufficient condition? Watch carefully. See, the left hand limit, this is the line. Right hand limit, this is the line. This point should also be here. You know, at this point also, the function should be present. So my condition would be limit x tends to 0 minus of f of x, that is the left hand limit, should be equal to limit x tends to 0 plus of f of x. Right hand limit, it should be equal to the value of the function at x is equal to 0. At x is equal to 0 also, it should be 1. Okay, equal to f of 0. Understood? Limit, if you put a value to the left of 0, if you put a value to the right of 0, and even if you put f is equal to 0, then the function becomes continuous. So this is my second understanding. Okay? Okay? It is not just enough that you prove LHL equal to RHL. You have to also prove that the function, you know, at this point also it should be continuous. So let's take a real life example. This is a house. Okay. So let's say there is a road like this. There is a road like this. Let's say this is what kind of road? Let's say this is NH66. Okay. So there is a person getting out of this house. Okay. So what happens is when he is getting out of this house, he sees there is a pool of water. Okay. There is a swimming pool. Let's say there is a swimming pool right in front of his house. Towards the right side of his house, that is towards the right side of his house, it is NH66. Okay, when he is getting out of his house, is looking to the right is NH66. Towards the left also, it is NH66. Okay, if he wants to go to the right, it is NH66. Towards the left also, it is NH66. Yeah, this is also NH66. But at the center, it is not NH66. At the center, what is it? It is a pool of water. You can't do anything. He cannot go anywhere. Okay, so let's say there is a car coming from this end. Will he be able to cross this road? Will this car be able to cross this road? Is this road continuous? Look at this. Is this road continuous? No. So that is why I'm saying it is not just enough that at this house, let's say his name is some Satish. That is what NCERT usually puts. Okay. So let's say his name is Satish. Towards the left side of Satish, it is road. There is road. Towards the right side of Satish also there is road. This is from Satish's perspective. Okay. But in front of Satish's house, there is no road. It's a pool of water. So how can this guy make this road continuous? It should be NH66 to the right. It should be NH66 to the left. Sorry, left and right. Yeah. And it should be NH66 in front of his road also. I mean, his house also. Okay. In front of his house also, it should be NH66. Then only this road is continuous. Otherwise, it's a broken road. It's not continuous. This is from Sati's perspective. But let's say there is Ravi. This is Ravi's house. Okay. So look at Ravi's condition. Even if when looking at Ravi, towards his right of his house and towards the left of his house, it's always NH66. Yeah. So for Ravi, it's always continuous. But for Satish, when there was water, when looking at from Satish, it is not continuous for him. So this continuity is defined at x is equal to 0. I'm not taking any other point. At x is equal to 0, the function was broken. Like we remember, no? For x not equal to 0 and x is equal to 0. The function, how was the function? The function was like this. It was broken. But let's say what is the function at x is equal to 2? Towards the left of 2 and towards the right of 2, it is always 2. So we'll come to that. Don't worry about it. But this is the condition for continuity, that this condition is only a necessary condition and this is a sufficient condition. You have to arrive at this. Okay. So please note it down. We'll go to the disciplined, civilized definition, not the, can be drawable without lifting your hand. That's not the definition. We'll go to the disciplined definition. Please note it down. So here is the more civilized definition for continuity of a function. That is, in general, if a function has its domain as a subset of real numbers. So reading all these things, students get very confused. So subset of real numbers has a domain. There is nothing to be worried about. It only says that, whatever value you take for x, domain means the values you take for x. You have already learned that in your relations and functions and sets also, your first 11th standard. So the function has its domain as a subset of real numbers means whatever numbers you are taking is a real number. That's it. There is nothing very complex in that. Let there be a point C. Let's say there are a lot of real numbers. There were a lot of real numbers. I choose which point? I choose 0. So here for me, what is C? For me, 0 is C in its domain. Then the function is continuous at C. That is, function is continuous at 0 if limit x tends to C minus, limit x tends to 0 minus is equal to limit x tends to C plus, limit x tends to 0 plus is equal to f of C, is equal to f of 0. This is for me, this is me checking the continuity of the function at x is equal to 0. If you want to check the continuity at any other point, so you can make it as C. Okay, this is some C. So this is a definition for continuity of a function. Very easy thing. You just have to check whether the road towards your right, the road towards your left and road in front of your house is all the same. Okay, that is what continuity means. We are talking about continuity of a function. Note the definition and we can apply this to more and more questions. Okay, children, I'll see you in the exercise.